Please support me through PayPal through devinwyndham@gmail.com. devinwyndham@gmail.com is one word, all lowercase. I tutor both online and in person. If you're interested in tutoring, you can reach me at that email. I'm based in Fairfax, Virginia. Please subscribe to my channel. I'll leave all this information in the comments. I want to talk about equations. So suppose we have 2 plus x equals 5. That's a statement, a mathematical statement which can be true or false based on the value of, depending on the value of x. If x is equal to 4, if we plug in 4 for x, we get 2 plus 4 equals 5, which is false. If we plug in 3, we get a true statement. So to solve an equation means to find all the values of x that make that statement or that equation true. So we, I mean, that's easy, we can do it in our heads, but it's, you know, sometimes equations are hard, so we've developed these rules for solving them, and these rules transform one mathematical equation or statement into another mathematical equation or statement without changing their truth value. So the equations will be both true or both false. In other words, they'll be equivalent. Those statements will be equivalent. We can connect two statements with a double-headed arrow. I use that double-headed arrow a lot in my YouTube videos. You can read that double-headed arrow as if and only if, or is equivalent to. I think I'll say is equivalent to for this video. So let's start with that equation, 2 plus x equals 5. If we subtract 2 from both sides, we'll get an equivalent statement. I'm not going to change the solution set. The solution set of an equation is the set of values that make it true. So we can say 2 plus x equals 5 is equivalent to x equals 3. And what I did is I added negative 2 to both sides. Alright, so if you think about it, you can convince yourselves that, you know, if we add the same number to both sides of an equation, we obtain an equivalent equation. Again, equivalent means it will have the same truth value. In other words, both equations will be true or both will be false. In other words, we're not changing the solution set. The values of x that make one equation true will be precisely the same values of x that make the other equation true. All right, well, convince yourself of that. It shouldn't be too hard. If we have an equation which just says the two quantities equal each other, and we add the same quantity to both sides, we'll obtain an equivalent equation. Now, when I say add, you know, we're sort of doing advanced math here. You know, we've studied negative numbers. I'm including, you know, basically all real numbers. You know what a real number is? It's a number you can represent on the number line. So when I say add the same number to both sides, that includes adding a negative number. All right, what else can we do to transform an equation into an equivalent equation? We can multiply both sides of the equation by the same non-zero real number, right? Note that I said non-zero because let's take that example that we started with, 2 plus x equals 5. If we multiply both sides by 0, we get 0 equals 0. What's the solution set of that? Well, there are no x's that appear in there, so if we're, you know, if the context is like finding all the values of x that make, you know, that's what we're dealing with in the background, all the values of x that make the equation at hand true. Well, any value of x, because there are no x's. So the solution set of 0 equals 0, you know, the equation we end up with is the set of all real numbers. That's not the same as the solution set of the original equation, which is x, you know, which is the set 3. So we can't multiply both sides by 0 and obtain an equivalent equation, but we can multiply both sides by any non-zero number, real number, right? And I said real number, that would include 1 over negative pi, 1 over negative 0.333. We can multiply both sides by 1 over negative 0.333 and obtain an equivalent equation. It may not always be the best thing to do, but they will be equivalent. What else can we do? So we've basically discussed adding to both equations, multiplying both equations. And I'm not going to say dividing, because dividing is the same thing as adding, right? Basically, just as I didn't single out subtracting, I don't have to single out dividing. So we have multiplying, adding. I mean, I guess I could do dividing, right? We can always divide both sides of an equation by the same real number that's not 0 and obtain an equivalent equation. I didn't include 0 because division by 0 is not defined, right? All right, maybe let's do some examples. So x squared equals 4. What is the solution set? Did you say x equals 2? No, it's not the complete solution set. Maybe pause the video, see, are there any more values of x that satisfy that equation, x squared equals 4? Well, there is, and it's -2. So the solution set is 2 and -2. Notice I didn't use any of the rules I just specified, I just sort of thought about it. So the solution set of x squared equals 4 is the set containing 2 and -2. Let's do x squared equals 9. What's the solution set? Well, it's a set containing the numbers 3 and -3. What about x squared equals 4? The solution set is the empty set. Again, we're dealing with real numbers. Let's say we haven't studied complex numbers yet, or I'll just specify we're dealing in real numbers. So that solution set is the empty set. There are no real numbers that satisfy x squared equals -4. Right? I guess you might say, well, what about -2? Well, -2 times -2 is +4, not -4. What about x squared equals 0? The solution set is the set containing the number 0. What about the square root of -4 equals x? Well, if we're dealing in real numbers, the solution set is the empty set because the square root of 4 is, did I say that wrong? The square root of -4 equals x. What about that one? The square root of -4 equals x. The solution set is the empty set because the square root of -4 is undefined. So you can't put any real number in that equation and make it a true equation because it can't be true, we'll say, if you have some undefined stuff in there. So we'll say the solution set is the empty set. What about the square root of 4 equals x? The square root of 4 equals x. By convention we mean 2, because 2 squared equals 4. You might say, well, about -2, because -2 times -2 equals 4. But when we say the square root of 4, I guess we should say the positive square root of 4, the principal square root of 4. But by convention, we don't mean we're going to do negative square roots. The square root of 4 equals x. The solution set is 2. All right, I'm going to stop this video here. I hope to see you in another video soon.